Okay, in order for us to handle this question, what we must do is to consider that the numbers, when we try to write our numbers now on the Venn diagram, we will try to write them as non-overlapping numbers. This means that I will not want to write down 28 students who take Spanish, and I will not write down 28 over here, because this 28 we do not know if it represents just this section over here or the whole section, or we do not know the numbers here as well. So what I would advise in Venn diagram is we always try to write everything as non-overlapping numbers. Okay, so if you read the question carefully, what we can do is always to take a highlighter and look at all the key numbers here. Okay, in addition, there are 2 students who take all 3 languages. So as you can see here, 2 students here who take all 3 language classes represent the number 2 here, which is overlapped by all 3 numbers. So over here, I start from the fact that there are 6 students which take Spanish and German, meaning in the area where Spanish and German interact is actually over here. If I take away the fact that this number is 2, this number will be 4. Okay, now there are 12 students which take Spanish and French over here. This means that if I have 2 students who take all 3, the number over here should be 10, because it's 12 minus 2 to give me the number 10. Okay, there are 4 students which take both French and German. So if this is a totality of 4 and 2 students are here, 4 minus 2, there should be 2 over here. Now if there are a total of 28 students who take Spanish, 28 minus 10 minus 2 minus 4, you can see that I'm left with a remainder of 12 here. I'll go in this order and find that my 11, French, German, and then there are actually 51 people left outside. So this is what you need to do in order to be successful at solving for your probabilities. And it is important that you get your Venn diagram numbers correct before you start the question. Okay, now I will not go through part 1 and part 2, because I believe that most of you are okay with these 2 parts. So what I'll go through is probably part 3. Now 2 students are actually chosen at random, and I want to find the probability that at least 1 student takes 1 or more language class. Okay, so alternative, what we can do is we can actually do what we call the complement method. Now this is the same as taking 1 minus the probability that both students doesn't take any language class. Okay, so because if at least 1 student take 1 or more language class, we don't even have this probability. The complement of this, right, is that we don't even have at least 1 student. We don't even have 1 student who take 1 or more language class, meaning both students that we choose, they take 0 classes. They doesn't take 0 classes. How would that work? Well, yes, all we need to do, if you can see that if we take 1, the probability of you getting a student who doesn't take 1 language class is 51 over 100. The second one will be 50, because 1 is taken, and have 50 over 99. And that gives us the total answer of 49 over 66. And that's done for part 3. Okay, now for part 4, we need to determine whether a student chosen at random takes German and whether take French are independent. So simply what we need to do is we find out that the probability of taking German and probability of taking French, we find that because there are a total of how many? A total of 16 German students. So it's basically 16 over 100. Okay, multiply by French student, which is 25. So this is 25 over 100. This gives us a totality of 4 over 100, which is equals to 1 over 25. Now be careful, because these are two different events, we do not need to put the number 99. Okay, so just be careful, we're not going to take the number 99 because this is probably of a German and probability of a French. They are not two sequential events. However, the probability of F intersect G, what does it mean? This means that a student chosen at random takes both German and French. So what's the probability? Well, if you look at it over here, the number of students that take both German and French is actually equals to 4. This means that out of the total 100 students, we have actually a probability of 4 over 100 of students taking German and French. Take a look at these two. They are actually the same. They are actually the same. Okay? Okay, so indeed, since the probability of F intersect G is equals to the probability of F multiplied with the probability of G, we can conclude that F and G are independent. Okay, so that's all for this video, and I hope you enjoyed it, and if you like it, please do subscribe to find out more. Thank you.